Hey everybody, welcome to Crazy Tech Lab, and Intel has finally announced its Arrow Lake desktop processors. So we have all of the specifications and indeed the pricing for its next generation Core Ultra processors. So lots of exciting stuff to go through today. We've actually got two of the processors here already in our press pack from Intel, ready for the embargo when we can actually talk about performance, and we will of course be using Z890 motherboards, which of course we have here from MSI with the stunning MEG Z890 Ace. So lots of stuff to go through today. We're going to be running through the specifications, the pricing has been confirmed, and we're going to be basically talking about the key takeaways from a recent press briefing that we had with Intel, and lots of interesting stuff about overclocking, about memory speeds, and the general performance uplift, as well as significantly reduced power consumption and temperatures as well, which I know a lot of you were concerned about with previous generations of Intel processors. So first up then, the specifications, and what we're looking at is a product stack that is pretty much identical in terms of core counts to the previous generation. And to start with the model names, they probably sound a bit weird. Obviously we've been dealing with Core i5, Core i7, Core i9 for such a long time that any kind of change to that, or significant change that we've got here, probably seems a bit daunting. But you can just think of it as Core Ultra 5 being equivalent to Core i5, Core Ultra 7 being equivalent to Core i7, and Core Ultra 9 being equivalent to Core i9. And in fact, the core counts for those things are identical. So you have 14 cores for the Core i5, you have 20 cores for the Core i7, and you have 24 cores for the Core i9, and the split between P cores and E cores is identical as well. For example, the Core i5 14600K had 14 cores split between 6 performance cores and 8 E cores, and that is exactly the same for the Core Ultra 5 245. Or 245K, should I say. And the CPUs that we're actually looking at, Intel has announced 5 so far. So we have the flagship, which is the Core Ultra 9 285K, which we have in this box. We're going to be looking at that in just a moment. We also have the Core Ultra 7 265K, and there is a KF version of that one as well. That has identical cores to the 14700K with 8 performance cores and 12 E cores. And moving further on down the stack, we have the Core Ultra 5 245K, essentially the equivalent of the Core i5 14600K, 14 cores in total, 6 performance cores and 8 E cores. Now, moving along the specifications, and we'll get to the pricing in just a second. The cores are the same, but what we don't have this time is hyperthreading. So Intel has ditched hyperthreading, and its reason for that is essentially that the makeup of the hybrid core architecture with E cores making a much more of an appearance here, not in terms of numbers, but definitely in terms of their performance, which we're going to get to in a minute. They're just not seeing the benefits from hyperthreading that they're used to in terms of how it balances out power consumption and performance. So it's already ditched it on its mobile parts, where obviously any kind of reduction in power is very significant. Less so on the desktop, but it still feels that ditching hyperthreading is the right way to go. Obviously that will mean a hit in multi-threaded performance, but Intel has assured us, and it actually responded to a question that I asked in the press briefing about hyperthreading, that it will still, or we will still see a performance uplift in terms of multi-threaded performance, even though it has ditched hyperthreading on its Core Ultra 200 series. So essentially the flagship here, the Core Ultra 9 285K, should perform faster in multi-threaded workloads than the 14900K. Now, in terms of frequencies, we are actually seeing a slight drop in frequencies. So there's a couple of hundred megahertz knocked off every single SKU in the range here. So don't expect to see, much higher frequencies out of the box compared to the 14th gen series. Now, the most important aspect here, probably for a lot of you, is the pricing. Now, it's reasonably aggressive, I think. I had a quick look this morning on Newegg, and I found, I think it was the Ryzen 9 9950X, and that was retailing for well over $600. Intel here claiming that the flagship Core Ultra, I'm still saying Core I stuff, Core Ultra 9 285K, the flagship with 24 cores, is going to retail for $589. So that is pretty aggressive, and part of that might be that Intel is aiming up against the 3D Vcache models when they come out. Likelihood is they might be faster than what Intel has here, looking at the figures. So it might be reining the pricing and just hoping that everybody opts for its CPUs based on their performance to price ratio. So the Next step down is the Core Ultra 7 265K, and that is going to retail for $394. So that's a pretty good deal, I think. And the KF model, there's no KF model for the Core Ultra 9, but there is a KF model for the Core Ultra 7. So the standard Core Ultra 7 394, and the KF is 379. So moving down to what is essentially the Core i5, the Core Ultra 5 245K. And obviously all the K series SKUs are overclockable. The KF model, the K model to start with, $309. I think that's a pretty good deal. And also the KF model 245 KF 294, so less than $300 for the Core i5 or Core Ultra 5. So some reasonably aggressive pricing there, but you do have to factor in that you will need a new motherboard. You cannot upgrade to a new processor without one of these because the socket has changed to LGA 1851. All the indications are at the moment that you won't also need to buy a new cooler, but there was a bit of a wobble from Intel the other day in the press briefing where it said you had to check with your motherboard vendor because there's maybe a slight difference in Z height of the processor or the way that the socket works. So that could mean that some coolers may need adapters and you may need to buy a new cooler, but I think we're going to have to check with cooler manufacturers to wait for their word on this. We're still a few weeks away from launching, so we can't really comment on that too much. And I literally received the samples this morning, so I haven't had a chance to test that. Anything like that with some coolers that I've got hanging around to see if the performance numbers line up, or the thermal results line up. So we're going to have to wait and see on that, but early indications are, certainly in terms of actually fitting onto the CPU, that everything is exactly the same as it was with LGA 1700. So obviously, motherboard's not backwards compatible either. You can't transplant your 14th gen or earlier model into a LGA 1851 Z890 motherboard as well. So you need a new motherboard, you need a new processor. The other thing that's changed is DDR5 memory. That is the only memory that is supported on this platform. You cannot use DDR4, so DDR4 needs to go on eBay or whatever you do with it. And that is pretty much it. So if you're upgrading from an older Intel or an older AMD system, a socket AM4 for example, you do need to buy DDR5, whether you're going for AMD's latest socket or Intel right now. So what other things have we had? So we've got identical core counts. We've already spoken about that. We've already spoken about the pricing. The other thing that we should probably talk about is the E-cores. So Intel has already made a lot of noise about their E-cores with their Lunar Lake mobile desktop parts, which were super impressive when I looked at them a couple of months ago in Germany. But they are ramping up the number of things that those E-cores can do for the simple reason, well, partly due to the fact that they've ditched hyperthreading, but also because they want to see those E-cores kind of taking up more of the sort of low to medium end tasks, leaving the performance cores to the higher end tasks. So we've got twice the L2 cache bandwidth with the new SkyMon E-cores in this processor, and the actual number of E-cores though hasn't changed like it has on other platforms over the last few generations. So that stays the same as the 14th gen models. So we are looking at about a 13% performance increase in general compute performance, but we are looking at a 32% uplift in performance on the E-cores compared to the 14th gen models. So that is really significant. So we're looking at the E-cores being able to handle more tasks, which means that the P-cores will be more freely available to handle more demanding tasks such as games and content creation and all that kind of stuff. Now, performance is it's kind of a bit of a mixed bag, even by Intel's own figures. We are looking at performance uplifts in multi-threaded performance, even though they've ditched hyperthreading. We're looking at single-threaded performance increases. But what overall we're seeing is a pretty much the same or maybe even slightly lower performance in games overall. Now, some games will see a net benefit. Some games will be slightly slower than the 14th gen series. And that's probably not what we'd expect from a new CPU launch. I know that AMD has already been criticised for what is essentially no benefit at all, pretty much across the board with its Ryzen 9000 series. A lot of stuff has changed here, so we're kind of seeing progress in some areas and a slight regress in other areas. But one area that Intel is saying it has definitely not regressed and actually sees massive increases in terms of how the processors perform is power consumption and efficiency. So this is something that we've all been hating on Intel for quite a while, and here we are going to see up to 165 watts lower power draw like for like, generation to generation. So obviously that's not hard to do for the 14th gen series. They were very, very power hungry and very hot running. But as well as significant power savings, we are also going to see up to 17 degrees C lower temperatures as well. So you might not need quite as lavish cooling to cool these things, so potential saving on cooling there. But we are also going to see significantly lower power consumption as well. So probably don't need to have quite as beefy power supplies. So some really, really interesting findings there overall in terms of the specifications, the pricing, and how these things are actually going to perform in the real world. It's going to be really interesting to test them. Now, when it comes to memory and overclocking and all that kind of stuff, obviously we're looking at DDR5 memory only, but Intel itself said that the sweet spot for DDR5 is DDR5 8000. So that is quite a step up from what we're used to with AMD. Obviously, AMD is kind of the benchmark for this. It's been supporting DDR5 for a very, very long time. There's lots of people out there with Intel systems that support DDR5 as well. So generally, we haven't seen that much benefit from increasing the performance, but the fact that Intel has said that DDR5 8000 is the sweet spot in terms of performance, etc., that is pretty interesting. So we're going to have to, I'm going to have to run out and try and get some faster memory kits and all that kind of thing. So what we've got in terms of overclocking, though, is again quite a different picture. So Intel, by its own admission, has said that the P cores are pretty much running near their limits out of the box. But that's nothing really that new. We've seen that for processors for a few generations now, and it's exactly the same with AMD. You usually have to pump a bit more voltage through them in some situations to get more frequency. And in some situations, you can actually rein in the voltage, make them run cooler, and get them to run at higher frequencies that way. So here, it's by its own admission, the P cores aren't really, or shouldn't really be, your first target for overclocking, which is pretty much the first time it has ever said that. The E cores is where you should be focusing your energy. So that is pretty interesting. And also, it has said that you will see other benefits from other areas of the system in terms of overclocking, and particularly the memory frequency and other frequencies on the system, but memory frequency especially, and the actual CPUs and the motherboards are very resilient to memory overclocking as well. So very, very interesting numbers here. Interesting specifications, some pretty aggressive pricing, I think, overall, but remains to be seen how this balances out in terms of performance and pricing and all of that kind of stuff. And what we're going to do now is just have a quick unboxing of this amazing press kit from Intel here. We're going to have a look at the new motherboard very, very quickly. And in another video out today, we're going to actually take a look at how to install a Core Ultra 200 processor in an LGA 1851 Z890 motherboard for the first time, to make sure that you guys that are coming from maybe a socket AM4 system where the pins are on the motherboard, just to make sure that you guys actually install it properly and don't end up bending the pins in the socket, because they are super fragile, and bending the pins is still a leading cause of motherboard RMAs. So don't forget to check out that video that's also out today. Also out today, I have a super cool video of a tour with MSI. So not actually looking at this motherboard here, but their Tomahawk Wi-Fi model. I actually follow it along the production line as it goes from a bare PCB all the way through to the end. So if you want to learn about and see how a motherboard is actually made, you can check out my tour video with MSI in Shenzhen in China recently, where I went across the whole production line. Super, super interesting if you're interested in how a motherboard is actually made. It's super cool. And also today, we'll be looking at a bunch of other MSI motherboards as well here on the channel. So that's it from me today. I'd like to thank Intel for sending over the press kit. We're going to be benchmarking these over the next couple of weeks to see how they perform. Thanks to MSI for sending over the MEG Z890 Ace. Looks like an absolutely fantastic motherboard. And all that's left to do is just to run through the unboxing of these two things. And also don't forget to like and comment on this video as well. It just helps punch me through the algorithm and gets me noticed. Don't forget to subscribe and turn on those notifications. And let's crack on with the video. Okay, so here's our kit from Intel, and we're going to have a quick look inside to see what we've got. And I've already had a look in here, and unfortunately there was a little bit of damage on the way. We've got a nice little desk plaque here with the Core Ultra logo and a nicely printed processor on there, and the specifications, if you want a reminder of those again, there on the back as well. So that's a nice little memento, and will probably find its way onto my YouTube background at some point. But the more important thing that we've got here are the two processors. So we have the Core Ultra 5. So as you can see there, that is the Core Ultra 5 245K. And of course, we have the flagship as well. And that is the Core Ultra 9 285K. So let's put the box to one side for a moment, and we'll have a look at the Core Ultra 9, I guess, because that's probably the one that everybody wants to see. I did try and take it out of its box earlier, but it was proving a little bit tricky, so I'm probably going to have to start just ripping things here, but no, there we go, we've got it. So, pretty much identical looking processor to its predecessor, the 14900K, and you'll probably be able to find some more analysis out there of these things, but looks like a pretty thick substrate down there, so I'd imagine that Intel would have improved the substrate to make it a little bit stronger, because obviously we had the bending issues and all that kind of stuff last time. Underneath here, there was actually a spare tile, because obviously they're using the Foveros 3D stacking technology in these things now. It did have like a spare area, and it had to fill it with like a filler tile, because obviously they're really concerned about just having a flat surface underneath the heat spreader. So just looks slightly elongated, and I know for a fact that a lot of the cooler manufacturers are basically catering their coolers to dealing with a shifted hotspot. So the hotspot varies from CPU generation to CPU generation a lot of the time, and that means that a cooler that will work great on one processor might not work on another one, even if it's on the same processor socket. So here we have a different hotspot, and there will be adapter kits and new coolers brought out to better cater for this thing's power requirements depending on where the heat actually is on the heat spreader. So just the back of the CPU, nothing really sort of that interesting to report here. So that is the Core Ultra 9 285K. So I'm kind of interested in how this thing is, how you actually manage to handle this thing. I would probably still go for a side-to-side mount, I guess, when putting it into the socket, or edge-to-edge. There isn't really, the heat spreader is quite flat compared to what you might have seen from AMD, or if you're coming from a Ryzen 5000 or earlier CPU, obviously that will be very different. But here we have quite a thin CPU to actually get hold of, so you'll want to watch my video of how to install this thing without damaging your processor socket. So now we're going to move on to the motherboard. So this is the MSI MEG Z890 Ace. So the MEG range down here, obviously that signifies MSI's flagship range. So this range includes motherboards such as the Ace and the Godlike. They're high-end motherboards, and expecting some suitably high-end stuff on this motherboard as well. We're just going to have a quick look at it today, because we've got lots of other stuff to do, and we're mainly focusing on the processors and specifications. I'll tell you what, this thing weighs an absolute friggin' ton. Absolutely ridiculous weight from this thing. It must be the VRM heatsinks, because I'm guessing it must weigh at least 3 or 4 kilos, possibly more. Wow, yeah, that is an absolutely stunning slab of a motherboard. And yeah, I mean, just look at those VRM heatsinks, absolutely enormous over here. So even though the new CPUs aren't going to draw that much power, MSI has certainly gone to town on the VRMs. The power circuitry on this thing looks absolutely insane. And we have MSI's new easy features. So we've got the pull and lift M.2 slot, and again we've got an RGB lighting connector down there as well, so super exciting. And these things are just so easy to install now. Look at that, I did that in 2 seconds, removed and lifted up the heatsink. And then we've also got the M.2 latch down here, so that thing just makes installing your SSD a lot easier. And tool-free as well. So, and obviously down here we've got a massive heatsink. And we actually looked at this motherboard in my other video as well. It was available on show at my my factory tour in China. So massive heatsink here. So whether you're using PCI Express 4 or PCI Express 5 SSDs, this thing will undoubtedly have what it takes to cool them. And on both sides of the SSD as well. The only trouble I had with this one is finding out where to actually secure things, but oh, there we go. There's a lot simpler than I thought it was. So we have a quick release PCI Express 5 mount as well. So the idea here is you can see the little thing actually moving. So you want to install your graphics card and then lock it shut like so. And yeah, you can either do it like that or probably just slot it in, but I just prefer to kind of push my graphics card in and then press that button and it kind of locks it. So now what we're going to do is run through a quick installation of the CPU. Now, I wasn't going to do this in this video, but I've got the CPU here and I've got the socket, so you can see a Core Ultra 200 series processor being installed for the first time on the channel. And of course, if you want a more detailed explanation of how to do this, I really recommend that you follow my video guide. So we are going to lift the socket. Now, this feels a lot different to LGA 1700. The socket feels longer. It's got a much longer arm, I think. So clearly mounting pressure is something of a concern for Intel. So for me, I think I would probably prefer to hold the processor end to end like that. That feels more comfortable to me. I can move my hand in and over the or into the processor socket from one side. You could probably do it like edge to edge as well. That would also work, but I kind of feel like I've got a better grip of it like this. So to move it into the socket, what I tend to do is just lower it right down so your fingers are pretty much touching the memory slots, move it over, and drop it into place like so. Now, the one thing I wouldn't want to do is kind of bring it down vertically. So if you see anybody like that, they're doing it wrong, because it's very easy to drop the processor into the socket and you're going to mash those pins and brick your motherboard. So you don't want to do that. So final step, as usual, close the socket latch and then we're done. So yeah, absolutely stunning motherboard, and obviously this is as fast as Intel gets on desktop at the moment. So that is a high-end Z890 motherboard and a flagship Intel Core Ultra 200 series processor in the form of the Core Ultra 9 285K. So that is it from the video today, and I want to thank MSI again for sending over the motherboard. Thanks to Intel for sending over the processors, and we're going to be looking at those very, very soon here on the channel. So that's it today. Thanks for watching. We're back with a lot more info on these things, and I'll be back very soon. See ya.